So recently at work, I've been researching a lot about LLMs, that is large language model, how they work and their internal architecture for a use case at work. So I've been learning a lot about how things work under the hood. So I thought I would document it. So today, let's see, if you ask a question to ChatGPT, then how it actually answers the question, what happens under the hood. Let's see how that works. So let's say if you have asked a question, why is the sky blue? And if you type this into ChatGPT, then let's see what actually happens in the next 2 seconds and how you get the answer. So firstly, what happens is the question that you asked will get split into chunks or something called as tokens. The underlying large language model, that is ChatGPT or OpenAI models or Gemini, they don't understand the words like humans do, but instead they understand numbers and their relationships. So the model cannot read English or any other language for that matter. So first, what it does, needs to break down it in smaller pieces called tokens. So here, if you see, tokens is nothing but splitting the whole sentence into manageable chunks. If you see here, these are each word is equal to a single token here. Y is a token, is a token, the sky and blue are tokens as well. But one thing that you have to remember is real frontier models like ChatGPT and Gemini, they don't tokenize a question in this way because it's really inefficient if you do it in this way just for the video purposes and just for the simplicity. I have taken word tokenization, but ChatGPT and large language models, they rely on something called as byte pair encoding. Tokenization it in itself is a very huge tutorial. We can speak a lot about how a question gets tokenized before it goes into the brain of LLM. Now, once it is tokenized, all these tokens are assigned numbers like this. If you see here, 2437 is a number I, 318 is a number assigned to is, and so on and so forth. And from there, any AI application, large language model application that you use, underlying architecture is called transformer. A transformer is a neural network architecture which all these applications use. So the underlying transformer architecture is something like this. So you can represent this in 3 layers. The first layer is input layer. The second layer is processing or brain, and third is output. So these are 3 layers that any architecture has these days. So once these tokens are passed into this input text and they are tokenized, and once it goes into embedding layer, it goes into a transformer block which has 2 layers again, self-attention and feed-forward network. So these are the main important brain layers that will fetch you answers, and then the output comes out. The output is, it will be a probability of what the next word token will be. If you see here, it uses softmax probabilities. Again, this can be taught in a very detailed, long tutorial and architectural explanation, but we'll just move on. So if you see, the entire flow runs per every word generated. So let's say if the ChatGPT gives 200 word answer, if you ask a question and the answer is a 200 word answer, then for each word, the ChatGPT will go through this architecture 200 times. So essentially, ChatGPT produces or predicts 1 word at a time. So for a 200 word answer, it will be 200 passes. Right. So as we have seen, after all those layers, the model scores every word in its vocabulary, and the highest scoring word wins. So all the ChatGPT and the AI applications are not deterministic, they are probabilistic. The outputs are probabilistic, and the output is not same every time because the outputs that each of these LLMs throw out are probabilistic in nature. So for the same question, the sky appears to be blue, what it will do is essentially get all the probable next words, and the highest probable word will be given out as answer. In this case, it is because of light. So for 1 word at a time, and this entire loop repeats for the length of the answer. So next time you ask ChatGPT, remember what happens behind the scenes. Your text gets chopped into tokens first, and then each token becomes a numbered vector because LLMs do not understand words like humans do. The words needs to be converted into numbered vectors, and then words check each other via attention. Attention and feedback are the brain of LLMs, and then these repeat to dozens of layers. Essentially, for every word or every token, the whole architectural loop kind of repeats itself, and then the answer comes out. So nobody has programmed the rules. So all the LLMs, all the large language models, they do not have deterministic rules that are written by any of the programmers. It is all the LLMs show something called as emergent behavior, which are very good in predicting the next word.